The purpose of this screencast is to give you an experience of what it's like to be a student in a decision-based learning class. So we'll begin, like in any decision-based learning course, we state the purpose of the course. So the purpose of this course is that you as a student will learn how to discern truth claims and also discern truth claims, evaluate truth claims, and be able to produce your own truth claims using statistics. We'll do that by targeting 3 learning outcomes. First, you'll learn how to select among 18 different methods. We'll give you a research question, and you'll be able to look at that and say, it's this kind of statistics that I should use. And we'll ask you why. Why would you use that particular method? And you'll have a very solid rationale as to why you chose that method. Then you'll have the ability to run those methods in a statistical software package that will be given you. And finally, you'll be able to report the results of that output of each method. You'll report the results in a way that a layperson who does not have a background in statistics could understand them. So we're going to begin. I have my student here, Chris Cardenas, and we'll start with a scenario that we will read. And Chris, could you read that for us?
Yeah, sure. Which facilities experience more safety anxiety measured on a scale of 1 to 10? U.S., European, or African facilities? You sample 101 from U.S. facilities, 89 from European facilities, and 83 from African facilities.
Very good. So Chris, we're going to start with a high-level question that an expert might ask when they first tackle a problem like this. And so could you read that first question?
Is this a descriptive or inferential question?
Very good. So we're going to imagine that Chris doesn't know the answer to that, so he or I can click on how do I decide. So Chris, you can see here that descriptive statistics are used when you want to know something about everyone in an entire group. So let's say, like it says, all customer satisfaction. Your company has 10,000 customers, and you're able to survey every single one of them. If you can do that, you're using descriptive statistics. If we were asking about everyone in the room we're in right now, then there would be 2 people, you and I. And so our satisfaction with a particular product, if they were asking how do Chris and Ken feel, then we would become the population. And therefore we would use descriptive statistics. Now, inferential statistics are more typical. They're used when you want to know something about everyone, but you do it from a smaller group. If you have 10,000 customers, it's unlikely you're going to be able to survey all of them and they're all going to respond. So you pick a random sample, and based on how they respond, it generalizes to the larger population. That's the idea. So Chris, we're going to go, well, could you explain back to me in your own words the difference between descriptive and inferential statistics?
Yeah, so it looks like descriptive statistics is used when you have everyone's information, and inferential statistics is used when you only have a portion of the population's information.
Excellent. Good. And then from there, you'll generalize to everybody.
Right. You'll generalize it to know the whole population.
So now we're going to practice. I want you to read each scenario and determine, are we dealing with inferential or descriptive, and explain why.
Okay. So find the average driving distance for all employees from home to work. So we're wanting to find the average, but it's for everyone, so we'll have everyone's information, which means it should be descriptive.
Very good. And there it is. And there, notice the clue in the problem is everyone or all in this case, which you said. You said. Very good. And so there's the definition. Okay, let's go to the next one. Could you read that one?
Yeah. What factors influence employees to stay at your company? You take a sample of 40 employees and generalize the results to all employees who stay. So it looks like you only have a sample of 40, and you want to use that small portion to determine what the factors are for the whole population. So that should be inferential.
Very good. Excellent, because we're inferring. Excellent. And there are the clues. The listener here will notice that in decision-based learning, we're always focused on the clues in the problem that determine which decision to make or how to classify each problem. Okay. Now, instead of going to the final example because of time, let's go ahead and go back to our original problem. Let's go back to our original problem. Now, as you look at this problem, Chris, what would you say? Is this a descriptive or inferential question?
So which facilities experience more safety anxiety measured on a scale of 1 to 10, US, European, or African facilities? We have samples from each, and they are going to be used to generalize the facility, so it should be inferential.
Very good. Now, normally in a class, Chris is actually a model student because normally in a class, students will say inferential, and then I'll ask why, and they give the answer. But the way he's done it is perfect. I like that too because he's proactive about it. So you'll find both ways of doing that in the class. Okay, so we're going to click on inferential. Up comes the next question. Now, if we had selected descriptive, that would have sent us down a different pathway. But since it is inferential, we'll go this way. Okay, Chris, the next question, is this a question of difference, relationship, or goodness of fit? So let's see how we're going to decide that. So with difference, could you read that?
Yeah. How do two or more groups, like younger and older drivers, compare with one another in terms of some outcome, as in their driving speed, average driving speed?
Excellent. So you'll see with difference, you have two or more groups and you're comparing the groups. You're comparing their averages. The next one is relationship. If it's a relationship problem, you actually only have one group. So does an increase in one characteristic, age, cause a change in another characteristic, flexibility? So let's take a sample of maybe 30, 40 people. Each one of those has an age, and each one of those has a degree of flexibility or lack of flexibility. And so we'll see, as your age increases, does your flexibility decrease or increase? That's a relationship question. And then finally, a goodness of fit question is when you have a claim, like 4 out of 5 dentists recommend flavored floss, does it fit reality? I go find 5 dentist friends and only 3 of the 5 recommend it. Does that reality support the claim? With goodness of fit, we're trying to see, does the reality, is it a good fit for the claim? Sometimes it's a bad fit. Okay.
Yeah.
So now let's practice. Could you read that one?
Yeah. Does employee morale increase significantly the longer they work at this company? You sample a group of 45 and generalize the results. So it looks like we're looking at the increase of employee morale and the length of time that they work at the company, see if there's a relationship between those two. So that seems to be a relationship question.
Very good. And like you said, those are the 2 characteristics. We're looking for the relationship between them. Excellent.
How do management and staff compare in terms of work satisfaction? You sample both groups and generalize the results. This one looks like a difference question.
Okay, and why is that?
Because it looks like that the management and staff are being compared, to see if there's a difference or not.
Very good. In terms of the average, in this case?
In terms of, work satisfaction.
Perfect. Excellent. Okay, let's go to the last one.
This one looks like a goodness of fit question off the bat.
Why is that? What's the claim and what's the results?
Well, you can see that salesman claims 95% of the employees increased their work productivity using his software. But it seems like once it's tested, they find that once it's sampled, they find that 86 increased their productivity. So it's not, we're seeing whether or not the results or the claim fits the reality.
That's right. Very good. Okay, now armed with that, just enough just-in-time instruction, that's what we call this. Look at the original problem and tell me what you think. Are we dealing with difference, relationship, or goodness of fit?
So this one definitely looks like a difference question.
Okay, and why is that?
Because we're seeing which facility has more safety anxiety.
Very good.
Comparing them
across the 3. Excellent. Okay, so we'll click difference. Now, One thing about the software, as students go through this, if we had selected the wrong one, then what it says is you've incorrectly classified the problem, return to the highlighted question. So it sends you back here so you can kind of relearn, okay, what did I miss with this particular problem? But Chris selected difference. Now at this point, because of time, we're going to just briefly go through the rest, and you'll see it's the same approach. How many variables of interest? Students now learn this concept, and they learn the clues in the problem that'll help them know what a variable of interest is and where is it in that problem and how many are there. In this case, there's one. Same thing. Is the variable of interest scaled, ordinal, or nominal? So we learn in the just enough, just-in-time instruction the difference between scaled data, ordinal data, and nominal data. In this case, it's scaled because it says scale, 1 to 10 right there. Then explanatory variables. We learn that concept. Notice in decision-based learning, you're still learning concepts that you would learn in a textbook, but this time, in this case, you're learning them when you need them to answer a question. And so decision-based learning for students is very goal or task-oriented. We don't just learn for learning's sake. We learn to actually solve a real-world problem. In this case, there is one explanatory variable. And I'm not going to go, the listener does not have to worry about learning these things right now, just to get a feel of how we make our way to the end. So then based on our decisions, which statistical method should be used? And so here's a how do I decide? And in this case, we learned that an independent sample t-test is used when your independent variable has 2 levels. So if I say, who drives faster, upperclassmen or lower class persons? I take their average driving speed, and year in school is the explanatory variable, and when you only have 2 levels of that, then you use independent sample t. A one-way analysis of variance, or ANOVA, is used when you have 3 or more levels. In this case, year in school, who drives faster, freshmen, sophomore, junior, seniors. An independent sample t-test mathematically cannot handle those 4 levels. It can only handle 2. So then you'd use a one-way ANOVA. So Chris, I ask you, as we go back to the original problem, what method would you use and why?
So I was thinking actually a one-way ANOVA because we're comparing 3 different facilities.
Very good. So we'll click on Run One-Way ANOVA. And
I
apologize.
Yeah.
We should have clicked right over here. Thank you, Chris.
That's a good experience.
Yeah, it's a good learning experience. And there we go. Now, in a typical decision-based learning course, you would have more information that would teach Chris how to run it in the software and how to interpret it so he can practice those other skills. And so this gives you a feel for the experience of going through a decision-based learning experience as a student. Notice, then Chris is ready for the next question, and the next question, and the next question. And he keeps taking them through, and the more he takes these problems through, he becomes fluent in not only the concepts and the procedures, but also the decisions that experts make.